Hi everyone, welcome to 15.2a arithmetic sequences. Okay, so we're moving away from, the function notation here of y equals mx plus b, and we're now going to be using a formula that involves that notation we talked about in 15.1, where we use the term numbers of a sub 1, a sub 2. Okay, so this is our formula. So pause your video and write this down. And we're going to talk about what each of these notations mean. Okay, so my formula, the way that it's read, a sub n equals a sub 1 plus n minus 1 times d. Okay, so a sub n. This is the nth term. Okay, that means that it's any term that we want to talk about. It's the last term for however many we're talking about. Okay, because n here is the term number. Okay, so note, n represents the term number so a sub n represents any future term. That also means that a sub n and n, they must match. So you can't be talking about a sub 7 and say that n equals 10. If you're using a sub 7, then n must equal 7. Okay. A sub 1 here, this is our first term in the sequence, and we know d. D is our common difference. So let's see how we apply this equation. So find the 12th term of the arithmetic sequence. So we're only dealing with arithmetic today. 9, 16, 23, 30. So if we want the 12th term, that means that we're looking for that we need a sub 12. And that also tells us that n must equal 12. There must be 12 numbers in the sequence in order to find the 12th term. So let's write down what we know. Okay, we're going to be using this formula, a sub n Okay, we know we're looking for a sub 12. We have a sub 1. That's our first term. It's 9. N must be 12. There must be 12 numbers in the sequence here. And then D, that's our common difference. So 30 minus 23, 23 minus 16, 16 minus 9, my common difference is 7. Okay, you've probably gotten pretty good at this point of finding your common difference. So now let's plug in all this information into our formula. So a sub 12, that's the notation for the answer we're looking for. Okay, now all of this can just be plugged right into your calculator. Plug it in exactly as it appears, parentheses and all. And we find out that our 12th term is 878. We want to make sure that we use that notation, a sub 12. Let's try it again. Find a sub 13. That's your future term. That's your a sub n, which means that n must be 13. They're telling you a sub 1, and they're telling you the common difference. We only have one formula to use. There should be no question about where to plug it in. We only have one thing to use. So let's plug in everything that we know. So we know we're looking for a sub 13. First term is 21. There are 13 terms in the sequence, and my common difference is -6. Again, plug that all into your calculator exactly as it appears, and we find out that the 13th term here should be -51. So right now you want to pause your video and try and work out these two examples. When you're done, the answers are written on the bottom. Okay, all of the worked out work for these can be found in the written completed guided notes that are posted on Google Classroom. All right, so now we're going to write equations. So this is going to be very similar. We're going to compare it to y equals mx plus b. But we're going to use this new formula in order to get there. Okay, it's just much more streamlined for us. Okay, whenever we're writing equations using this formula, just like in y equals mx plus b, we leave the y and the x as variables. We're going to leave our a sub n and our n as variables so that we can find any term. Okay, so in order to be able to use this for any term, we leave those open. So what information do I have here in example 3? So I'm going to need a sub 1, and I'm going to need the common difference. Those are the only things that should be filled in. So a sub 1 is 5, and I can determine here that I got from 5 to -13 using a common difference of -18. So I'm going to plug those into my formula, leaving these a sub n for any term. I can simplify this because I want it to look more like a linear equation, just not using y equals mx plus b. So we're going to distribute the -18 and then we're going to combine like terms. Okay, so you can see, so this is our final answer. This is the equation. So we could find any term number that we wanted now. And if we just write y equals mx plus b below it, you can see how it compares to that original form. So let's try and do another one. Okay, this time, write the equation for the nth term. See, it even says here, we don't want a specific term. We want to leave that open as n. Okay, and I'm looking at the information that I'm given. I have a common difference, and then I have a sub 4. Well, a sub 4 is not specified in my formula here. Only a sub 1 is. So this is going to be a two-step problem, and step number 1 is going to be to find the first term of this sequence, where a sub 4 is 32. So if a sub 4 is 32, that means that n must be 4. So we're not writing the general equation just yet. We're trying to solve for a sub 1 because that's what we need to plug into our formula in order to write the equation. Okay, so 4 minus 1 was 3, and 3 times 42 is 126. So we can solve this equation now for a sub 1. So I like to use the formula and solve for a sub 1 rather than taking the common difference and working it backwards. So I understand that in this case it's only a sub 4, and you could just subtract 42 a few times to get back to your first term. But what happens if they give you a sub 500, a sub 167? You don't want to have to work that common difference backwards that many times to get to the first term when you can very easily plug it into the formula and just solve. Okay, so we get a sub 1 equals 94, but that's not what the question was asking. We want an equation. So step 2, now we can actually find our equation. Okay, so for any term, leaving a sub 1 open, or a sub n, I'm sorry, I now have my first term. Okay, and we're again going to distribute. And combine like terms. So this is my final answer. This is my equation. That's what we were looking for. So this example number 4 here, definitely a little bit more complicated, and it's tricky because you might not realize initially that, oh, I need the first term and they're giving me the fourth term. So let me use the information from term number 4 to figure out what term number 1 was. Okay, we have 2 problems to try on our own, so pause your video, check back with your final answers, and if you'd like to see the work, you can consult the filled-in guided notes on Google Classroom. Okay, so we have some more. Write the equation and then find a specific term. So it says find the 32nd term where the 8th term and the common difference are given. So when in doubt, always start by finding term number 1. You always need the first term. Well, I know the 8th term, it's 30, and I can use that to find the first. Okay, 8 minus 1 is 7, and 7 times 4 is 28. So a sub 1 is 2. Okay, so that's our first step. Okay, our second step, you could either write an equation to then plug into, or you could just set up and solve for a sub 32. So I now know my first term, and I'm solving for n equals 32. Okay, plug that into your calculator exactly as it appears, and we find out that a sub 32 is 126. Okay, let's do it again. So find a sub 12. This is the 12th term. Okay, when the second term is 3 and the common difference is -7. Okay. Now typically we know we use the formula to solve for the first term, but the fact that we're given a sub 2, I am just going to work this one backwards. So I'm going to add 7 and find out that a sub 1 was 10. Only because it's the second term. Any other term, I would have plugged into the formula. Okay, so I'm going to use that to now solve for a sub 12. So the 12th term in this sequence should be negative 67. Okay, 2 examples for you to try, so pause your video, check back here for your final answers. The last type of problem is the one where we have to solve when you're given non-consecutive terms. When they're missing, they're called arithmetic means. So means are missing, using alliteration here. Okay, so find the arithmetic means in the sequence negative 8, question mark, question mark, question mark, question mark, 22. So each of those represents a missing term, which tells me there's 4 terms in between them. So what information can I get simply from what we've just written, from what the problem gives me? Pause your video for a second and see if you can write down, come up with what given information is here. So what are they telling me? A sub 1 is negative 8. There's 1, 2, 3, 4, 5, 6 terms. A sub 6 is 22. That's my last term. And there's 6 of them. The only thing that I don't have is the common difference, how I got from one term to the next. But I can use my formula, only one I've got, and plug in the information that I know. So that last term of a sub n, the actual term is 22. Okay, the first number was negative 8. There's 6 terms. I do not know the common difference, so I'm going to solve for it. 6 minus 1 is 5. Makes this a 5D. So we're going to solve this like a regular equation. Great, we got our common difference, but that was not our final answer. Okay, our common difference is just how we're going to find those 4 missing terms. We're going to apply it to the sequence that they gave us. So negative 8 plus 6 is negative 2, plus 6, plus 6, and we want to make sure that we accurately arrive at 22. So these 4 in the middle were a missing term. That's my final answer. Let's try it again. Okay, so find the arithmetic means in this given sequence. So how many question marks do I see? 4. So set this up. Okay, and pause your video to write down what information are they starting me off with? What's given here? Make sure that you can interpret this problem with these blanks. Make sure that you know what that information means and that you can write it down. Okay, were you able to translate that into a sub 1 equals negative 14, a sub 6 equals negative 54, and n equals 6? If you were, great. If you were not, you want to pause your video right now and you want to ask questions to make sure that we can arrive there. So now we're going to plug all of this into our formula. 6 minus 1 is 5, so 5D. And again, we can solve this equation. Whoops, 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 I changed my numbers here. There we go. Okay. We're going to make sure that we're showing all of our work and how we arrived at this common difference of -8. Okay, but remember that's not our final answer. We have to apply it to our sequence. So we're subtracting 8. And we want to make sure that we mathematically arrive at -54 as our last term. Okay, there's 2 more problems for you to try on your own. Your final answers are given and all of the problem work is shown on the guided notes posted in Google Classroom. If you have any questions at this point, you want to pause your video and make sure